In this video, we are going to learn how to work out the median of a set of data, continuous data, using a histogram. So first of all, let's remind ourselves of what a histogram is. Well, first of all, what it isn't, it is not a bar chart. It is actually something which shows us continuous data, data which is really squashed together, not discrete data, things like test scores or people's height, people's weight, and so on. So the y-axis actually shows us something called frequency density, and the x-axis shows us, scores or something that we're trying to measure, but it does so using potentially uneven class widths. Now, I want you to keep the concept of density in mind. Okay, so if I talk about the mass of an object, we know that that is volume times density. You don't really need to know that anymore, but it's a useful analogy. Mass we can think of as the amount of stuff. Now, in terms of statistics, that's generally going to be frequency, the number of people, the number of faulty parts on a production line, the number of cars passing a certain shop at a certain time of the day. Frequency. Now, volume is space. It's the space that something occupies. A 3D object will occupy a certain amount of space. That is volume. In terms of a histogram, that's going to be the width of each of the bars. It's going to be what we call the class width. The density is how close together, the density of a solid object is basically how compressed, how close together the material is. If we think about number density, which is electron density, you can think of the density of the electrons in a part of a circuit, in a piece of circuit wire. Or we could think here about how closely together the test scores are grouped in certain class widths. So we can see that between 100 and 120, there are a lot of scores. There are a lot of scores in this region, relative, so in terms of how close together they are. So we can say that that is what we call the frequency density. So I'm going to say frec density there because I can't quite fit it in, but it's frequency density, which is what we measure on the y-axis. So let's have a little look at this. This histogram doesn't tell us how many people had a score between 80 and 90. It doesn't tell us that yet, but it tells us, but with this formula, we can work out how many there are. So let's do that, okay? So between 80 and 90, we have a class width. So if I do 80 to 90, we have a class width of 10. And I've got that by just doing 90 take away 80 is 10. It's the width of the bar. The frequency is going to be that class width of 10 multiplied by the frequency density. Just think about it in terms of volume, the amount of space, the width of the bar, times by the density of the values, density of the scores. And if we read the scale, we can see that we're going up 1, 2, 3, 4, 5 little squares, means a frequency density jump of 1. So that means every little square is worth 0.2. So here, the frequency density is 2, 2.2, 2.4, 2.6. So I would do 10 times 2.6, which is 26. So that means that there are 26 pupils who had scores somewhere between 80 and 90. And we can work similarly to work out the total frequencies of each of these bars. So for this second one, and let's do it here because there's not much space at the bottom. Again, we have a class width of 10, 90 to 100, frequency density of 3.2. 10 times 3.2 is 32. You would usually have a calculator for these questions. The next one, class width of 20, frequency density of 5. 20 times 5 is 100. Next one, class width of 20, and a frequency density of 3, which gives us a frequency of 60. And the next one, 170, take away 140 is 30, that's our class width, times by a frequency density of 1.4. And a little trick, we can think of that as 3 times 14. I can just say this is 3 times 10. 10 times 1.4 is 14. I have 3 times 14, which is 42. Next, we have 170 to 200, another class width of 30. I multiply that by, well, the frequency density is no, excuse me, 0.6. Same trick again, 30 times 0.6 is just 3 times 6. Just rearranging the factor of 10, and that gives me 18. So what I can do, I can work out the total frequency. I can work out how many pupils were surveyed. So I can just add up all of these scores. So I have 26 plus 30. Oh, there's a mistake. That should not be 32. That should be 3.4. So this should be 34, my mistake. So I have 26 plus 34 plus 100 plus 60 plus 42 plus 18. And that gives me, so 30, 50, 60, 160, 220, 262, 280. So there were 280 pupils shown in this histogram. Okay, and notice I have not added up the heights of the bars. That's what you were taught in year 7 when you were looking at bar charts. That's not what we're doing here. This is a histogram, continuous data. Okay, so how does this help us find the median? Well, think about what we've done. We have class widths, which is, think about how you'd work out the median from a group frequency table. Well, you wouldn't actually work out the median. All you can do so far at GCSE is work out where the median is, which class width, which class interval, sorry, contains the median. Well, we'll start by doing that. Let's find out which of these bars has the median value in, or which one we can estimate as having the median value. And to do that, let's understand what is actually going on. The class interval 80 to 90 has a frequency of 26, which means that there are 26 pupils with scores between 80 and 90. So this person, could be the lowest score, could be 80, it might be 81 or something like that. It's between 80 and 90. So this person is person number 1. Person number 2 is also going to have a score. So I'm basically putting all of the people, I'm basically arranging all of the people in order of score. Okay, imagine I'm going to write all 280 people down. I'm going to get them all in a nice big, I'm going to go to the sports hall or something like that, maybe go onto the field probably, and get them all in a line in order, lowest score to highest score. So the second person might have a score of 81, could be 81 and a half, they're doing half marks, there's continuous data, and so on. So third person could be something like that, all the way up to the 26th person. And I can guarantee that the 26th person is going to have a score which is no greater than 90. So, the 26th person could be here. I don't know why they're holding up signs with their scores. You'll have to take it up with them, and so on. Okay, so that's the first 26 people with scores between 80 and 90. Now, the next frequency is 34, not 32, I made a mistake earlier. 34 people. And they have scores between 90 and 100. So, we could be thinking now, it could be 91, it could be 90 again, up to 100. Now, let's think about it could, again, it might not be exactly 100, it might be 99, but let's just say it's 100. Because they're not going up in ones here, okay? We're not saying that necessarily they're uniformly distributed. We do assume that in our work-ins, but there we go. Okay, so think about it now. The first person in this second bar is going to be the 27th person measured because, we've got 26 people in the first bar. The next person after that will be the 28th, 29th, and so on. Up to what? Well, there are 34 people that I've put in red. 34 people in the 90 to 100 class interval. So that means that we just need to do 26 plus 34. So we need to do up to 60. So that means that the last person in the second class interval will be the 60th person measured. So we can see that basically to work out how many people there are with scores between 80 and 100, we just add up the frequencies. 26 plus 34, okay, that's 60. And then if I do, if I want all of the people from 80 all the way up to 120, I would do 60 plus 100, 160, and so on. Okay, and if you add up all the frequencies, then you would get the 280, that's everyone. Okay, so we could carry on like this. We could carry on drawing the people, and I'll tell you what then, you could think about where the median is by just going halfway. The median value is halfway, right? You learned that at year 7. I put my people in order, okay, and in fact, they're in order in the histogram, okay? They're going 80 to 90, people with scores 80 and 90, People with scores between 90 and 100 and so on, they're in order. To find the median, we want the middle value. So all I do is I look at how many values there are. There's 280. There's going to be 280 people. Now, I'm not going to sit there and have one person on one end, one person on the other end, and go, and keep taking equal paces to the middle till you meet at the middle. No, we're going to think like mathematicians. We're just going to do 280 halved. So 280 divided by 2, 140. And then, we know that the 140th person, that person will be the median. Okay, their score will be the median score. Okay, so we need to find the 140th value. Well, you can probably tell me now where the 140th value is going to be in terms of which bar it's going to be in. It's going to be in the third bar, because we know the first bar contains 26 people. The first two bars altogether is 60 people. The first three bars is 160 people. So the 140th person is not in the first because there's only 26. He's not in the second because there's only 34 in there, which means there's only 60 so far. But by the time I get to the end of the third bar, we have 160 people. So the 140th person must be in this third bar. And just indicating that at GCSE, showing that you are now looking in the bar, 100 to 120, that class interval, that is enough to get us about 3 marks so far to work out the total frequency, halve it for the median, or divide it by 4 for the lower quartile. Show that you're searching in this bar, you've now got 3 marks. So keep that in mind. Now, this is where we get to the A-star territory, or the AA-star territory. But don't be discouraged. What we're going to do now is take it further than we did with group frequency tables. We're actually going to find an estimate for the median. So we need the 140th value. We know the first 60 values are in the class interval between 80 and 90, 90 to 100. So we need to go and find where or how far into the third bar we need to go to get to the 140th value. We know there's 160 values between 80 and 120 in terms of class interval. So we also know there's 60 between 80 and 100. So we need to know how much further into the third bar do we have to go. So how much further? Well, in terms of frequency, we can work that out. It's just going to be how much do I add to 60 to get 140. So I do 140, take away 60, which is going to be 80. So that means I need to go 80 in terms of frequency now into the third bar. A lot of people go wrong here. They say, oh, it says 100 plus 80, but that doesn't make sense. 180 is way up here. That would get me way out of where the median should be. So no, what we need to do is work out how wide we need to make a class interval in order to get a frequency of 80. Now look at what we know. In the third bar, this bar here, or the third class interval I should say, the frequency density is 5. Always write down any information you know. Frequency density is 5. We need a frequency of 80, because that will take us from the 60th value, the 60th person, it'll take us 60, 61, so all the way up to the 140th person. And we want to know how wide the bar will be, because if I know how wide the bar will be, I know exactly how much further to the right from 100 the median score will be, and I can just add on to 100 to get my median score. Now we can use the formula that we started with, the formula that we derived from mass, volume, and density, and we can work out the class width by rearranging. We know frequency is class width times frequency density, or frequency density times class width. To get class width on its own, I divide by frequency density on both sides. You may have been taught bring down the frequency density, it becomes a divide. That's fine. So my class width is frequency over frequency density, or divided by frequency density. So that, to substitute my numbers in, I get 80 divided by 5, which is just 16. So that means that the bar, this bar within a bar, if you like, this interval in the interval 100 to 120 needs to be 16 units wide, 16 score wide, whatever it is, and it needs to be to the right of 100 because we know the first 60 are in the first two bars, so we're going further to the right to get to the 140th. So we need to go 16 to the right of 100. 100 plus 16 is just 116, and that is my estimate for the median. Now, to work out the lower quartile is very, very similar. So I'm just going to erase what I have here. So there should be a way of erasing it all, but no, I'm going to have to edit this out later. I might not edit it out actually because I want to upload this. I want to get this up to you quickly. So I'm just going to delete all this, although I probably will have to write a lot of it again. There we go. That'll do. Okay, that'll do. So basically, what we want to do now is work out the lower quartile. The lower quartile is much the same, only instead of dividing the total frequency by 2, we divide it by 4, because we want to know where the lower quarter value is. We want to know at what value do 25% of the values in the distribution lie below. Okay, so the lower quarter. So this time we're going to take all the people, all 280 people, and put them in a line and find where the lower quarter value is. And to do that, to find the position of the lower quartile, all we need to do is 280 divided by 4. So be really careful. Don't automatically do the median. If the question asks for the lower quartile, divide the total frequency by 4, which in this case will give us 70. So, like before, we want the 70th value. So I want to put all my people in order of their scores. But this time, I want to find where the 70th person is. And again, let's look at our frequencies. The first 26 people have scores between 80 and 90. The first 60 people have scores between 80 and 100. So once again, we're going to be in the third bar because the first 160 people have scores between 80 and 120. So that means, we can say the first 160 people have scores somewhere between 80 and 120. We want the 70th score, but we know that the first 60 people are something like this. The first 60 people have scores between 80 and 100, so the 70th person's got to be in this third bar. So again, it's the same principle. We know they're in the third bar somewhere, the third class interval. So the frequency density is going to be 5. We do not know how far into that third bar we need to go, so the class width is unknown. We do, however, know what the frequency is going to be. We know the first 60 people are in the class intervals between 80 and 100. So in this interval, we have the first 60 people. So we need to go a further 10 people to the right. This gap is 10 people. So that means the additional frequency is just another way of saying how many values. The additional values we need, the number of them, is just 10. So we do the same principle. We do class width is frequency divided by frequency density, but the frequency is 10 and the frequency density is 5. So I get a nice 10 divided by 5, which is 2. So that means I need to go 2 units. So I could even draw that on if I look at the scale. I need to go a further 2 units into my third bar. 2, 4, 6, 8, 10. Further 2 units in, which is just this little slither here. So this area that I've just shaded very badly represents 2 people, and I can see that the lower quartile is 102 people. Now you might be asking yourself, well, that's very close to the median, but that is the beauty of a histogram. We can see, just by looking at the shape of it, you can see most of the values are concentrated down this end. So it sort of skews the lower quartile to that end. Okay, so it makes sense that most values are down here somewhere. Most values are concentrated in this bar, in fact. So it makes sense the lower quartile is around about that end. So in any case, the lower quartile is just 100 plus 2, which is 102. Okay, and as promised, I was going to go a bit further. Let's work out the upper quartile too. So hopefully that makes sense. If you want a challenge, work it out on your own. See if you get the same answer as me, because that'll really show that you understand this. Okay, or at any point now, as I work out the upper quartile, pause the video at different points. See if you can anticipate what I'm going to do. See if you can work it out. Okay, so let's work out the upper quartile. This is uncharted territory because this is not something which is on the mark scheme or anything. Let's do it. So to find the upper quartile, I'm going to take my people now. So, and I want to go, you can either think of this as going 3/4 from the bottom. So 3/4 from the first value up, or I can go 1/4 from the end value. So basically this time I've got my 280 people. And I want to work out 3/4 of that in order to get 3/4 in from the lowest score. So 3/4 times 280, you're going to get 210. If you don't like that, think about it like this. Think about taking 1/4 of 280. So that's 70. So you've got 1/4 of the distribution, and you want to go back by 1/4. So that means you just do 280, take away 70. This might be how you do, if you think about cumulative frequency, which is not exactly the same because it measures cumulative frequency on the y-axis, but it's a nice little analogy. So your cumulative frequency graph will look something like that, but joined up with straight lines. Let me make that very clear, abundantly clear. Median, you go halfway up, go down. Lower quartile, you go 1/4 of the way up, you go down. Upper quartile, you go you go 3/4 of the way up, right? Like that, 3/4 of the way up. Or you can think, okay, work out 1/4 of the total frequency and then go down by that. It's the same. Okay, so in any case, we're going to go and find where the 210th value is. So let's do that. So we can use our workings from earlier. So we know the first 160 values lie between 80 and 120. Then we have 60 values here. So 160 plus 40 is 200, another 20, 220. So that tells me the first 220 values lie between 80, so this is the scores, I say values, I mean scores, they lie between 80 and 140. The first 160 lie between 80 and 120, doesn't get me far enough. The first 220 lie between 80 and 140, so that means the value I seek is going to be in the class interval 120 to 140. It's going to be in here somewhere. Now it's the same procedure. Let's see how much further to the right we need to go. So the first 160 values are between 80 and 120. So how much further have I got to go? Well, I want to get to 210. So I just do 210, take away 160, which is 50. Yes, it is. 40, 50. Right, okay. So I need to go a further 50 in terms of frequency. Think about number of people, frequency. Another 50 in terms of frequency into this bar between 120 and 140. Don't want the whole thing. I just want to go in far enough to get me a frequency of 50. So let's think about what we know. We know the frequency density. We know that frequency density this time is 3. We know that we want a further 50 people. So we need a further frequency of 50. And we do not know the class width. I want to work this out to know how much further into the bar I've got to go. So we use our formula again. Frequency density is frequency divided by class width. I rearrange it. Frequency is class width times frequency density. Think of it like a formula triangle if you want to. Class width is frequency divided by frequency density. So let's do frequency, which is 50 divided by a frequency density of 3. These are not nice numbers, which gives me, 48. 3 into 48 goes 6. No, it doesn't go 16. 3 into 48 does go 16. Yes, it does. So I get 16 and 2/3. To check that, it is 16 and 2/3, I'm sure. Yeah. Okay, and you need to go that much further to the right from 120. So we go 120 and 16 and 2/3, so 10. I'm just going to draw it on for the sake of it, but it really doesn't matter. 120 plus 16 is 136. 4, 6, and then it's 2/3, it's like maybe about here. so we can actually see that it is there. Okay, so the 16 2/3 values, or roughly 17 pupils, is represented by this area. And we just need to go 120 to find the upper quartile. 120 plus 16 2/3, which is 136 2/3. So the reason you get the 2/3 is because it's continuous data. Really, it's going to be about the 137th. And that will give us the upper quartile. And again, you can see, well, it's sort of at the lower end of the distribution. Well, that's because there are so few scores that are above, 140. There were not many scores. In fact, only 25% of the scores are going to be above this. And then you can sort of check that. If you do 280 by 4 is 70. And if you think about it, 136 2/3, if you add 70 to that, then you roughly get 200. It's a bit more, but that's because this is an estimate. So that should be an estimate for the upper quartile for the scores. So hopefully this has explained how we work out the 3 quartiles from a histogram. And finally, you might be asked to work out the interquartile range. Interquartile range is simply the upper quartile, take away the lower quartile. So that in this case would be 136 2/3, take away the lower quartile of, what did you work it out as, 102, which will just give us 34 2/3. That would be the interquartile range. So hopefully this makes sense. If you've got any queries about it, please just let me know. Leave a comment and I'll be glad to help you.